Hello everyone, thank you for coming today, and thank you for joining us at the Tech Academy for one of our Friday Tech Talks. We're very fortunate today to have Derek Meyer speaking about the introduction to cryptocurrency and blockchains. It's a big buzz, so we're very fortunate to have him share. So with that, let's give a warm welcome to Derek.
Awesome, thanks guys. So we're going to look at some of the basics of cryptocurrency, and we're going to take a look at some of the technical aspects of it. Quick background on me. I was first introduced to cryptocurrency in 2012 by doing a process where you verify transactions. It's called mining. We'll get into that as we go through. And then took a detour off, got really interested again at the beginning of last year, and since then I've just been totally enthused with it. So let's get started here. First off, what is a cryptocurrency? It's a virtual currency that uses cryptography, which is the action of making information unreadable so it can be kept secret. You guys have heard the term encrypted, right? Okay, good. Comes from the same place. So yeah, virtual currency that uses cryptography to verify transaction details and thus display accurate balances before and after a transaction is complete. One of the original purposes of Bitcoin, which is everyone familiar with what a white paper is? Okay. It's a quick rundown of what the purpose of some new thing will be. And in the white paper, they mention a lot the problem of double spending transactions. Like if I were to write Michael a check for $100, and then I also wrote Isabel a check for $100, but I only had $100 in my bank account, the person who's going to get my $100 is whoever goes to their bank the fastest. Even though I gave Michael the check first, he wouldn't necessarily get that money. So Bitcoin was first introduced to help solve that problem. And then it got more and more advanced. So before we go too far into cryptocurrency, I want to talk a little bit on just some of the attributes of money as a subject. Throughout history, we've had a lot of different forms of money, such as carved limestone. Has anyone ever heard of rhinestones? I'll show you what it looks like. Yeah. Yeah, they're huge. They're like, this big. They sit on the beach. And that was used as a way to figure out who has how much money. There's a lot of problems with that as a currency. Namely, it was very difficult to take around. You couldn't take that to the store and buy eggs with it. So they found better versions. Salt was used as a form of currency for a while. In Russia during the medieval times, they used squirrel pelts, which isn't a very efficient form of money, which we'll see in a sec. We've used precious metals such as gold and silver. Nowadays we have paper bills, like our current dollars. And economists have found a few key attributes that make up an efficient system of money. The first one is portability. Is it easy to take around with you? Obviously those big old rocks, not super easy, not a very good system of money. Salt, that's relatively simple to transport, at least in small amounts. You won't be able to take like too much money with you. Squirrel pellets, although they are portable, it would kind of smell as you were taking them to the store. Precious metals, such as gold and silver, it's relatively portable, but in moderation. You wouldn't necessarily want to walk around the street with 12 ounces of gold on you, necessarily. And then paper bills are very portable. You can take those wherever you go. The next one is durability. A good system of money needs to be durable. Carved limestone is very durable. If it rains, your limestone will stay there. Salt, not quite as durable. If it rains, you lose your money. Squirrel pelts, not at all durable. After a bit, it decays, and you don't want to use that system of money anymore. I have a feeling that's why that one didn't last very long. The squirrel pelts fails most of these 6 categories. Gold and silver are both very durable. Other precious metals, very durable. Paper bills are fairly durable, unless someone's going around tearing up money, but very few of us in here have ever done that, I'm sure. The next one is divisibility. One of the big problems with carved limestone is if you want to buy a small object, you need to be able to divide your money to purchase different sized items. So with carved limestone, you would have to like chip away at that rock and give someone a smaller rock from your rock, which would be pretty difficult. Salt is very divisible. Squirrel pelts, we don't want to divide those for multiple reasons. I'm sure you can imagine. Gold is somewhat divisible, but not down to the point where it would be usable as a standard form of money. One of the smallest units of gold that are really looked at is like 1 ounce. But 1 ounce of gold is worth about $1,300, so you're not going to go buy things in ounces of gold. And then paper bills, we have all kinds of different denominations of dollars. We've got a $100 bill, $10 bill, $20 bill. You've got pennies, dimes, quarters. It's fairly divisible. All right, this next one, it's pronounced fungibility, which means if you had two of the same thing, are they equal in value to you? Like if I were to offer you two $1 bills, does it matter to you which $1 bill you take? Not at all. Something like squirrel pelts, that would matter, because squirrels are different sizes and different colors, and you'd probably want to pick a favorite color. Gold and silver are very fungible. It doesn't matter to you what 1 ounce gold coin you get, as long as it's a 1 ounce gold coin. The next one is scarcity, which this one's important because you can't introduce a whole bunch of money into your economy, otherwise that causes problems. Things like limestone was relatively scarce at the time that it was used. Salt was stopped being used as a currency when they found that it wasn't scarce. Squirrel pelts, I guess that's as scarce as in a ratio compared to how good we are as hunters. For gold and silver, those are both very scarce. And there's a certain amount that's mined throughout the year, but it's not very much. And then lastly, paper bills. That's one of the big problems with our current monetary system is that we can print money whenever it's deemed that we need to or want to. And the last one is verifiability. Is it easy to counterfeit? With paper bills, it's pretty hard to counterfeit. I don't know that anyone of us could do that particularly easy, but it does happen. With gold, that's pretty hard to counterfeit. You could try to plate something as gold, but it's pretty easy to detect if that's pure gold or not. Squirrel pelts, that one's very verifiable. If someone throws a dead squirrel on the counter, you know that that's a dead squirrel. Salt is pretty easy to verify. You could just taste some of it and you're like, yeah, that tastes like salt. But then you're losing the durability of your money. And then carved limestone, I would imagine that would have been pretty hard to counterfeit at the time that it was used. So one thing with cryptocurrency is that it excels in each of these 6 categories. It's very portable. You can take it around in your phone, from your laptop. You could be walking around with $1 on your phone or $1 million, but you can transport your money very fast. The other thing that's great about the portability of digital currency is that you can also send it all across the globe. Durability. This is a point that I would argue that cryptocurrency isn't actually as durable as people claim it to be. Because with the way that it's structured, which we'll look at this on a later slide, but you could actually lose your login credentials to your money, and then it would be locked out forever. And no one would ever obtain that Bitcoin or that cryptocurrency in the future. Divisibility. This is a very common misconception with cryptocurrency. People sometimes see Bitcoin and it's at whatever price, and they're like, oh, I can't buy that. What other ones are there? But you can actually buy a fraction of a Bitcoin. So rather than buying 1 Bitcoin, you could buy 0.01 or 0.001 or 1/100 millionth of a Bitcoin. Fungible, 1 Bitcoin is always equal to 1 Bitcoin. There's no difference between them. Scarcity, there's, in total, kind of fun fact, there will only ever be 21 million Bitcoin. Right now there's a small amount that's being trickled into the system as people verify transactions. But once it hits 21 million, no more Bitcoin will ever be created. And lastly, the verifiability of Bitcoin is all built into rules in the protocol of how transactions are sent. So in order for something to go through, you'd have to first make sure that the funds are accessible, the person has that much money, and that the address that you're sending to is a valid address, and the whole thing is verified before the transaction goes through. Now, in addition to the attributes of money, there's also different purposes of money. There's a fourth one, which I didn't include in here, but there's 3 major ones. One of them is a medium of exchange. So back in the bartering system, if I had eggs and Michael had a gallon of milk, and I wanted to have Michael's gallon of milk, I would give him eggs, which was workable until Michael no longer wanted my eggs. And so they used a system of money to give, whatever the money system was, so that Michael had the same value as my eggs, and he could go transport it to a baker where he wanted to buy a cake. Good, a unit of account. So this is how we value things. Each person has a different profession and a different trade, but we all measure what we're buying using the same system of money. For example, Eric Gross, founder of the school, doesn't go to the grocery store and pick up a gallon of milk and go, this is about 1/100th of a tuition. Instead, he measures it in money. So he says, this is $2 or whatever it is. Another great example of a unit of account is, has anyone here ever been to an arcade? Yeah. Good. So you know that different machines cost different numbers of tokens, right? Yeah. So there's the big ones that cost 4 tokens, and then there's the small ones that cost a token. That's all a unit of account, so you can see the value of playing whichever game you want to play. The last one is a store of value, and this one was more introduced when you had, by having a bank account, you want to be able to keep your money where you have your stored value or your wealth in that bank account. Other assets can add to your store of value, like if you have fine art in your house, or if you had a golden table in your house, that would add to your store of value. If you do have a golden table, let me know, because that would be awesome. So those are the different purposes of money, and some cryptocurrencies are stronger in some of these aspects than other ones, which we'll also get into later. Okay, so what is Bitcoin? Bitcoin was the first real cryptocurrency. It's a virtual currency that uses a distributed ledger and a network of computers to verify transactions. We're going to break down what that means. Before we go into the next slide, though, there's 2 key terms that I want to define ahead of time. One of them is called a public key. It can also be referred to as a public address. So this is an address that you send to others when you want them to send you Bitcoin or another cryptocurrency. You can think of this like your email address. If you want someone to send you an email, you give them your email address. Then you have something called a private key, which is a string of letters and numbers which you only know, which is essentially like your password to allow you to send your Bitcoin elsewhere. This is something that you would not give to other people. Unless you want them to steal all of your money. So in this sentence here, so a virtual currency uses a distributed ledger. So first let's look at what distributed means. There's different ways that systems can be set up, whether it's or any type of system. It could be a database, it could be something having to do with government. In this case, we're having to do with money. Currently, the way that fiat currency, which is government-issued currency like U.S. dollars or yen, etc., it's run through a centralized system. So there's one entity that kind of controls it, and then it goes out to others. There's something called decentralized, which a lot of people will say that Bitcoin is decentralized. It's not actually the case. It's distributed. And a decentralized system could be like, our standard economy. If we say that this dot right here is Joe's painting company, right? Joe buys supplies from a painting supply company. So Joe could increase his prices, but that doesn't affect the other businesses around here. But if the supply company increases their prices, that affects multiple people. And then if commodities, like wood, for example, for paintbrushes, they increase their prices, then that affects other people. There are some cryptocurrencies that are distributed and some of them that are decentralized. So with Bitcoin, you have a ledger, which we're going to look into that on the next slide as well. But the ledger is actually spread through everyone. And everyone has a full copy of all the transactions that have ever happened in that ledger. And so it looks closer to this example here. Okay, good. So a virtual currency that uses a distributed ledger. Let's take a look at what the ledger looks like. So this is another misconception. So with Bitcoin, there are no actual coins. Yeah, there's no coin. Instead, it's a ledger which is used to see how much each person owns. However, your identity isn't stored in the ledger itself. Instead, you have your public key, which we mentioned earlier. So you can see in the example down here, you see Joe has 1 Bitcoin. That's this B right here is the symbol for Bitcoin. So in the ledger, you wouldn't see that Joe has 1 Bitcoin. You would see 1 EHNA6Q, etc. has 1 Bitcoin. Now, if Joe wanted to transfer half a Bitcoin to Amanda, Amanda would send him her public address, and he would say, "Hey, send Amanda half a Bitcoin." And then that would go through the verification step with the computer network, and then the ledger would now say 1 EHN, etc. has 0.5 Bitcoin, and Amanda, or 1 CDSPH, etc. has 100.5 Bitcoins. Does that make sense? Okay, cool. Another fun fact is that you can have multiple public addresses linked to your private key. So like your password for accessing your Bitcoin, or in the email example, the password to access your email, you could have multiple emails associated with that password. And the reason for that is, like, let's say I wanted to send Michael $30 worth of Bitcoin to pay for pizza. So Michael would send me his public address, and then I would then see his public key right here. It says Keith. Let's assume that it says Michael for this example. So he sends me that. I send him 0.05 Bitcoin, and then he receives it. If I was really nosy, I could say, I wonder how much money Michael has. So I look up his public key in the ledger, and I see, oh, he's only got the 0.05 Bitcoin that I sent him. That's unfortunate. But yeah, so you can have multiple public addresses linked to your private key. So even though I look up his balance because I want to see how much money he has, I don't know that he has other wallets or other public keys. So it looks like he only has 0.05 Bitcoin, but actually he has 1,000.05 Bitcoin, because this is also Michael's. Once that thing goes away, okay, good. I put Keith on there, but we're going to assume it's Michael. Sorry, the question was, is your public key random, or is it constant with your private key? There's something in cryptography called a hash, where you enter in a certain amount of information, and then it generates this random ID. And if you change even one letter on it, it changes the whole outcome of that hash. So like this right here is a hash. The private key could look, oh, actually, fun fact, the private key for this address is 1. So if you wanted to access the funds in this wallet, there isn't actually 1 Bitcoin in there, there's no Bitcoin in there. But if you wanted to access those funds, you could put in, for the private key, 1. It's not a very good password. But yeah, so what happens is someone enters in the 1, that's their private key, and then they make a hash, and it generates this public address right here. Now, you could enter in, for your private key, you could say, okay, good, so 1 plus Joe, because that's the person whose wallet it is. And it's going to give you a totally different private, or a totally different public key. So you can generate multiple of those. Yeah, and so the question was, how do you keep security if someone can look at your addresses? Well, you can have multiple public addresses. And a lot of wallet softwares out there will give you a different address for each transaction that you do. That way you're not just building up a running record of how much money you have. So someone can check your address to verify, like, hey, I just received funds from this person, or I just sent funds to this person. I want to make sure that it arrived okay. You look it up, everything arrived okay? Okay, great. But you can constantly generate new addresses to make sure that you're not keeping all of your transaction records. Otherwise, someone would just have access to like your whole banking history, which would not be good. So yeah, so you can generate multiple public addresses linked to your private key, and we'll get into this a little bit with the next slide. But when someone's verifying transactions, that process is known as mining. As you verify a transaction, you get paid a transaction fee from the person who's trying to make a transaction. But in addition to that, you get rewarded in a portion of Bitcoin. And that's where that trickle comes in, where more Bitcoin are added into the system. And it was estimated that by the time that there's 21 million Bitcoin, the transaction fees for mining are going to outweigh the amount of Bitcoin created. So at that point, they're just like, great, no more mining fees at that, or no more Bitcoin created at that point. Mining fees will take over the job from here, and then you're stuck with a 21 million. It's a great question. Basically, what happens if you lose your private key compared to the total supply? Quick answer is that that's gone. No one will ever be able to access that again. There's stories of people storing their private key on a USB stick and then losing their USB stick. That's happened, if that happened to you years ago, you just lost a lot of money at this point. And there's constant horror stories just of security in the cryptocurrency space. People will delete a line of code and all of a sudden lose out on people's private keys. So it's a huge issue. But to that extent, Bitcoin is something that's known as a devaluating currency, where it'll reach the certain point of 21 million, and then after that, the supply slowly drops down. There are other cryptocurrencies that don't have the same cap, such as there's no cap for the second largest cryptocurrency, which is called Ether, from a project called Ethereum. A great example of how cryptocurrency can be used is people talk about the concept of remittance, where someone comes to the U.S., they start working, or any country at that, they start working, and then they send money back home to their family in a different country. Well, there's all kinds of fees associated with that, and that takes a certain amount of time because there's borders in between where you're sending your money. With cryptocurrency, it's something that can be done instantaneously with minimal fees associated. So like some of the concepts like that, like how are we going to actually use this stuff? That's what I try to focus a little bit more on. Again, so a virtual currency that uses a distributed ledger and a network of computers to verify transactions. So there's a distributed network of computers. Anyone in here can turn their computer on and start verifying transactions, and you would essentially join the Bitcoin network. One other quick aside, one thing that's very confusing with Bitcoin is there's the Bitcoin network, which is this system of computers, and then there's also Bitcoin, which is the currency that you hold. Those are two separate things. In other projects like Ethereum, there's the Ethereum network, and their currency is called Ether. So you can already separate the two of them. But so with mining, in order to conduct a transaction with Bitcoin, where you send information of who you want to send your Bitcoin to, it goes through a network of computers. Now these computers, when you turn it on, you say, "Great, I want you to mine." Start that. It basically participates in a bunch of guesses, and it starts guessing at this mathematical problem. Very similar to like if you had a key code that you had to enter in 4 numbers in order to get into something. So then your computer says, okay, 1 1 1 1. Okay, that didn't work. 1 1 1 2. Okay, that didn't work. 1 1 1 3, etc. Until eventually it's like 4 5 8 9. Oh, it worked. And then at that point, you'll have solved the mathematical problem. Now, all of our computers, if we were all mining, they would all be trying different guesses at the same time. Now, whoever wins, or essentially whoever gets the code right first, they get to then take a bunch of transactions that are waiting to be confirmed and include it in the latest update of the Bitcoin ledger. And that latest update, that's called a block. So they're trying all these transactions. They finally get it. They're like, okay, great, I've got this block. And then they see all these people want to make transactions, and who's going to pay me the most fees? These guys will. Okay, good, let's put it in there. And then you tell every other computer in the distributed system, say, hey, the code to that problem was 4589. Oh, and by the way, here's all the transactions with a new update. And everyone tries 4589. Oh, it worked. Okay, hey, good for you. Let's try the next one. And then they start again. 1 1 1 1. Nope. 1 1 1 2. So after you get enough of those blocks created, where someone finds the right code, includes transactions in it, they create a block, send it out. Happens again. You start to get these chain of blocks, hence a blockchain. So what are the incentives? One, it's a lot faster than most money systems, other than cash. That's relatively instant. If you give me cash, I then have your cash, and I now have that value. But in a digital system, if you're sending Bitcoin, it could take about an hour for the person to then be able to spend that elsewhere. But that's still a relatively fast system. There are other cryptocurrencies that are even faster than that. I would say most other cryptocurrencies are faster than Bitcoin. In fact, my next slide is just simply altcoins. Let's talk about them. So there's a lot of different type of alternative cryptocurrencies and alternative blockchains out there. There's one, for example, called Patientory, and their blockchain is used to store medical records in an encrypted format. Last year, we had a couple of hurricanes in the U.S., in Texas as well as Florida, and there are stories of hurricanes going through the hospitals and destroying medical records, which happened. We'll never get those medical records back, or the patients and their care providers will never get those back. On a distributed system, you wouldn't, even if one of those computers got destroyed, the person's medical records would stay strong, and they'd still have access to it. That's just one example. There's a lot of different asset tracking blockchains out there to figure out, where has my car been? You enter in the VIN number and you can see who's owned it and how. Whether that gets implemented and we start seeing it in more use, that's the question. Okay, good. So let's, one of the biggest, or I guess the second biggest cryptocurrency, or the biggest alternative to Bitcoin, is called Ethereum. Now, being that we're in a software developer school, this one's going to be particularly interesting, because Bitcoin operates on a very simple payment system, where you say, Joe pays Peter 1 Bitcoin. That's all there is to that protocol and the transaction. Ethereum operates on something called a smart contract, which is a programmed contract, and they have their own programming language called Solidity. which is similar to Python. So you could say Joe sends Peter 1 Ether if today is Peter's birthday, and if Joe has at least 100 Ether, and if, all these different conditional statements, else if return to sender. And so then that contract goes out onto the blockchain, and if all of the conditions check out, and today is in fact Peter's birthday, and Joe has at least 100 Ether, then that transaction would occur. So essentially what you're developing in that is a contract that is a self-fulfilling contract, which the really cool thing about that is it removes the necessity of trust in a contract. Has anyone ever gone out like off of Craigslist to purchase a car? Just like through a person? Oh, I'm the only one. Okay, there's a few people. Yeah. So when you do that, you go and you give the person money. And you're like, hey, transfer the title to my name. Make sure that happens. You could write a contract that just says, hey, here's the contract. I already put the money into this. Once you transfer the title, it's going to send you the money. If you don't transfer the title in 60 days, it's going to give me back my money. So in that example, you no longer need to trust the person selling you the car that they're going to go and transfer the title. You know that'll happen, because if they don't, then you get your money back, and you're going to have to figure out a way to get them back the car, otherwise you have a stolen car. But you know that they'll fulfill that. And as the seller, you know that you trust yourself that you're going to transfer everything. And once it transfers, then you get your money. Another great example is like with houses, like the average cost of escrow fees for a real estate transaction in Oregon is like $1,200. And they're just kind of being the in-between point as a trusted third party. That's something that could be completely automated. It'd be a much larger contract than the previous example, because you'd say, okay, transfer $300,000 worth of Ether if all inspections are done, and all inspections passed, and buyers approved on lending, and the price is agreed upon, and all the different steps that go into buying a house. But once everything is done, the funds transfer. And rather than costing you $1,200, it costs you $4, and whatever time it took you to write the contract. So that's just another use case. But there's plenty of business to business use cases for developing contracts that don't rely on trust in order to be fulfilled. Okay, good. Litecoin. That's the second one here. Litecoin is basically a light Bitcoin. It's smaller, faster, cheaper. Pretty simple. You'll after you do some research into like how to obtain Bitcoin, Litecoin is a very popular, I guess, next option if you don't want Bitcoin. And the last one that we'll talk about here, and then I'll open up for more questions, then we'll end off, is a cryptocurrency called Ripple. And Ripple sometimes gets a little flack in the space because it is not distributed. Instead, it is actually decentralized. So it operates a little bit differently in that everyone doesn't necessarily have their own entire history of the Ripple transactions. And in fact, you can't even mine Ripple. But what its focus is to help solve some of the bank-to-bank transfers, and just more the digital cash side of cryptocurrency. Like they're working with banks in Japan to send money to South Korea. And rather than it taking however long that previously took, it takes 3 seconds. So they're one of the, they're a larger alternative to Bitcoin that focuses a bit more on payment processing and bank-to-bank transactions. But yeah, it's another one of the big ones out there. Okay, awesome. Well, Michael, that's all that I have